Hello, I'm Mark Benison, and this is our 3D platformer tutorial looking at shooting in Unity. We'll be using raycasts, although there are other approaches such as use of rigid bodies and having physical projectiles. But we'll be using rigid bodies and we'll be looking at creating an enemy. We're going to be using a tutorial we worked on previously where we've already got player ready, but by all means use your own player if you have one. And we're going to create a script that will add to the player, and that is going to look at the shooting mechanic using the raycast, and we'll have a health manager that will add on to the enemy so that we can manage its health points and have it get killed. And we'll do the same the other way around. We'll have the enemy be able to focus on and shoot back at the player, and have a health statistic on the player as well. That's what we're going to look at. It's going to focus primarily on first person mode. Third person will cause potential issues or may cause issues because the third person model might get in the way of the shooting. So you need to bear that in mind. You might need to move the player off center if you're doing third person, and you may want to look at slightly different mechanics for how you make it work. You should also be aware of where we're shooting from. We're looking at shooting from the camera, so the middle of the screen of whatever you're looking at, which typically is how games do it. I've seen some people try and have it so it's where the gun physically would be shooting from. It doesn't always work well in a game mechanic sense to have it just directly shoot from the gun, but you can sometimes have it work that the gun and the eyes marry up to the same position and see what it comes out with. So that's a case of if anything gets in the way of the gun but not your eyesight, it would hit the object in question. And that is certainly better for third person, but again, it takes a bit of effort. You have to target using your camera and then shoot from the gun, and it's a slightly extended mechanic, shall we say. Let's get started. So I created this previously. It's just a sandbox scene. I've got a player object with a third person controller and a first person controller, or components, or models and cameras and things. And my player object has a script, and it's set to the first person perspective so that it'll switch into that when it starts. I have an environment which is just basically a load of cubes and a ground plane, and they're white and green, so we'll just go with it as it is. Let's start in our assets, and in fact, sorry, before I do, I'll just press play to show you what happens here. When I press play, it will be in a first person view. You see it went red there, that's because it's my first person model. I can move around, but I can also press tab and go into third person view, and you see now it's the blue model, which is my third person model, so I knew that there were different models. Now I'm going to be, as I say, working in first person. Right, now we're going to go to assets in our project pane, and we're going to create our folder structure. I've already got player folder, and within that I've already got scripts folder, so I'm going to be adding 2 scripts to that. I also want another folder for the enemy, and I want a scripts folder inside the enemy. Inside the enemy scripts folder, I'm going to create 2 scripts. I've got enemy attack and hit manager, and under the player scripts I'm going to create 2 scripts here. And here I've got player attack and health manager. Each time you add a script, you have to typically wait for the code to be added. And we're going to I'm going to open all these in Visual Studio Ready, and then I'll come back in here and start creating the enemy object. So I'm just going to open these up. Here I've opened all scripts. I've got health manager, hit manager, player attack, and enemy attack. I'm just going to leave them for now, and we'll come back to them. I've closed down any other scripts I had open from the previous tutorial because that's not the focus of today, and I don't think I need to edit them or do anything with them. So if you've got your own system you want to build this into, it could potentially work. Back then in Unity, we'll get started by creating our enemy object. So I'll start with an empty game object in the scene. I'll call this enemy. And within that, I'm going to add a capsule, so a 3D object capsule. And I'll call this enemy model. This is over the back here. We'll resize this in just a moment, or reposition this in just a moment. I just want to explain. I put the enemy model as a capsule inside an empty game object rather than just create the capsule straight away and call it enemy, because I want to be able to swap the model out later without having to change all the code. So I want to get it working with an empty game object and a model I can remove. It doesn't need its collider, though you could take a note of its details because we could actually use those inside the enemy itself. But I'm going to leave it on. Going back to the enemy, I always want to make sure that these things are positioned how I want them to. The enemy model, I'm just going to have a 0, 0, 0 for now, while I reposition the enemy base. What you don't want is the enemy base to be offset massively from the model. The idea is the model should be central to the enemy base, the parent. So we're going to set this up how I expect to see it. This is going to be on the ground. Happy with that location there. But I don't want them to be in the ground. Now with the player, I positioned the player so that their center was on the ground as well. So they're 0, 0, 0 when they're grounded. So the enemy's going to be the same. They're on 0 on the Y when they're grounded, sorry. It's on the Y that matters. Y is your up and down. So the enemy model I'm going to move up to 1 so that it rests on the ground where I expect it to. If you wanted to resize the model, you'd have to change its positioning appropriately. So if you went for a 0.7 scale, you'd have to position it 0.7 on the Y. Now this is a scale, this is not an actual size. This has a radius of 1 and a height of 2. Sorry, a diameter of 1 and a height of 2, I believe. But its scale factor is 1, 1, 1. I'm not a huge fan of resizing them. It's something that you should get the models right and then put them in ideally, but it's there if you need it. You don't want to be changing the enemy base to the parent to be a different scale ideally either. It's a model that you can adjust directly. If you change the enemy, it'll change anything inside of it, and that can get confusing and messy. Because I want to know which direction this thing's facing, I'm going to create another object inside this, and I'm going to call it the gun. I'm going to do the same thing which I've done with the enemy model and create a placeholder empty game object, and then within that we'll just place a cylinder for the same reason that I can then swap out the model more easily. So create an empty. This wants to be inside, but I'll call it gun. It's not where I want it to be, so I'm going to put it inside enemy, not inside the model, just inside the enemy there. And I'm going to position this 0, 0, 0, and this is relative to its parent, so it's just going to be inside. In terms of the enemy, is at -10, 0, 0, which means the gun is in the same position as the enemy, but relative to the enemy, it's in 0, 0. It's at the enemy's origin point. So the origin is your 0, 0, 0 point. It's local to the enemy. Now, I'm going to leave that there a second while I create a cylinder inside of it. I'm going to call barrel, the barrel of the gun. I'm going to rotate and change this, so rotate it 90 degrees. Sorry, that's scale. Rotate 90 degrees on the X, and that means we've got sort of forwards and backwards on this. And then I'm going to resize it. .1, 0.3, 0.1. So 0.3 is its height, or now is length because I've changed its height. I can reposition this however I see fit. Actually, apologies, I'm not. I'm going to set that to 0. And I'm going to move the gun itself to where I want it to be. Now, the reason I did this as well is if I rotate a barrel and just put a cylinder in, its Z, which I consider to be its forward-backward movement, a positive Z value should be forwards, now is facing down. It's a blue line, so it's now facing downwards. I say that and it changes something else altogether. It's making a liar out of me. Well, so be it. The reason I'm doing this as well is that the barrel, its forward position will typically be wherever the blue arrow is facing, which will be down. So if it was to move forward, it'll move down. And I want it to move forward as far as the gun's concerned, which will remain forward and backwards on the Z axis. I'm now going to position the gun itself, the barrel being 0, 0, 0 to the gun. Now, I'm not trying to make this look realistic. I'm not trying to offset it up to the side. I just want it at the front, almost Dalek-esque, because I'm actually doing this more so I know where the front is than anything else. I want to colour my enemy as well, so I'm going to create a new folder in Assets called Materials. That again. Called Materials, and then create within that a material, which I'm just going to call Black. I'm going to actually set it to a more of a dark charcoal. Paste that in on top. I could do the same with the barrel if I wanted. I'm not going to. Now, I'm going to add the two script files I created, enemy attack and hit manager, to my enemy. If I click on the enemy, I should see enemy attack and hit manager in the files there. I'm going to go to the player object and add in the two script files we created for this. I'm going to first add player attack and then health manager to that. Doesn't matter about the order, I should say, whilst I'm saying which order I'm putting it in. Okay, so we've created our script files, we've added our script files, we've created a model to represent our enemy. We can zoom out and decide where we want to position this. I need to be able to have an overview of what's going on, so I'm going to set it back here. And now we can start coding. I'm going to start with the health manager file. And I'm going to delete these comments. I'm going to delete them both now. I'm not a big fan of keeping those comments in. And I'm going to start by having a serialized field attribute for the variable I then type, which is a float. It's a private float as it happens right now. I'm going to call it hit points. I'm going to set it to default 100. We actually don't need the start and update, so I'm going to delete all of that. Don't forget to keep your open brace and close brace, which is for the public class. The class has an open and close. You can actually minimize these as well and expand them. So if you're trying to work out what's where, and Visual Studio gives you plenty of indications, but you can do things like collapsing locks down. We'll create a private subroutine called hit. And we'll have a parameter which will be called raw damage, and it'll be a float type that we'll pass into hit so that we can apply a damage value. Now, if we had armor on our character, we could take the raw damage that should be caused and then do some deductions to work out what actual damage we want to apply. For the purposes of this, I'm just going to go for a straight raw damage is damage. We want to deduct raw damage from the hit points of the player. So we do hit points, minus equals will deduct the value that comes after the equal sign from the variable to the left. The raw damage will be deducted from hit points. It's the same as saying, I suppose if I just type this up briefly to show you what it looked like. These do the same thing. A minus equals is a bit shorter, so that's why we use it. We'll do a debug log for debugging purposes. And we have to output a string. So I've got a string that says ouch, and I'm putting a colon and a space so I can append in what our actual hit points are. Now, hit points is a float rather than a string, so the right thing really to do is do a toString method at the end to make sure it's a string. Although it didn't come up with an error, so it might actually work and convert inherently, but there we go. I'm going to put it in for the what I feel is more correct. Now we need to ask a question. Okay, if we're going to be deducting hit points, what happens if our hit point goes below 0? So at least let's ask the question. If our hit points are less than or equal to 0, we need to do our game over, you died script here. Now, I'm not going to do that now. something for you to look at later, or when you look at menu systems and you revert back to the menu or something coming up. For now, we just need to make a note that that's where we put our script. So you could have a to do game over. For now, also I like a debug log. That's it for our script. Let's copy it, everything between the braces, between the public class braces. Get that out. Go to Hit Manager, highlight all the code in here, delete that, and paste in the same code. I'm going to make some subtle changes. I'm going to change the default starting value to 25. I'm going to remove the debug log to say we've got a hit. This is now going to be used for the enemy. And if the enemy is killed, we're just going to invoke self-terminate. IntelliSense will ask for a time as a float value, and this is a time that it says will be in seconds. We can do it as 0f and it'll remove the enemy straight away. What I love about this though is we can have the enemy removed after a period of time. You might think, why would I want to do that? Well, you might decide to start off an animation sequence where the enemy will start to fall over, and you might want them to fade away even after like 10 seconds, and then you want to remove the object from the scene. So you could look to delay how long before it self-terminates, or you could just call a subroutine and have the subroutine manage the whole process as well. Different ways to do it. We do want it removed, and quite happy for it to be removed straight away. If you were delaying how far before it removed to do some animation sequence, you'd also need to think about, you don't want the enemy to be able to shoot while it's doing its animation to die, and everything else. After the void hit, but still within the class, let's create our self-terminate. Which will run destroy game object, and that's actually what's going to remove our object here. Nothing to stop you taking that and putting it in here instead. But again, this gives us an opportunity to delay things. It gives us an opportunity to add more to the self-terminate to determine how it'll work. You can actually choose to put a time in the destroy to determine when you want to remove the object, and that's probably more closely aligned to what I was saying about deleting the objects after a period of time. That's our hit manager. Our player attack. Because we can't test health manager or hit manager yet, so I need to have some sort of attack mechanic to try it out. I'm not going to need the void start, and I'm going to get rid of those comments. I'll keep the updates because we're going to use that. I'm going to start with a transform for the camera transform, which is where we're going to do our shooting from. I'm going to have a range which I'll hard code into be 100, which is going to be how far we'll allow our shooting mechanic to work. I'm going to start with a raw damage as well, of how much damage this shot will do. And again, we could tailor this to be something that would change depending upon how far away it's hitting something. It may have a maximum damage it does when something's close, but when something's further away it does less damage, depending on the kind of weapon you want to make. But again, I'm going to hard code these to these values. We'll have to go back into the inspector, and because I added them into the inspector quite early, we're going to make sure the values are set in the inspector. Right, if you write the script first and add them in, sometimes that's probably a better way to go. Right, on update, I'm going to run a script, subroutine that we haven't yet created called fire weapon. Obviously this doesn't exist, so we need to create it. Update will run multiple times a second, so every frame if you like. I'm going to check for the fire weapon, where we're going to ask the question, are they pressing the fire key? We're going to use Fire 1, which is the left mouse button or I believe control in Unity, and you can set these through the input manager within Unity. At some point I'm going to look at configuring controls dynamically rather than hard coding them in, but not the scope of today's session. If they press the button down, so the first thing is I want to set our camera transform. I never set it, I just created it. I didn't create a start to set it there either. My camera changes depending on which view I'm in, so I wanted to have the opportunity to swap which camera I'm using. I'm setting it to be the camera's main transform. So camera main finds whichever camera is currently live and is set to main. You may want to check that with your cameras. You have the main camera tag. I believe it uses that for main, although I haven't checked, but I believe it does. I've got two cameras, as I say, a third person and a first person camera. Admittedly, I'm only really focusing on the first person, but I wanted the script to at least try and work with either camera setup. We're creating an array, and we're doing this on its own line just to separate code out a little bit. And we're looking at defining it as having a start position of the camera's position, wherever the camera is based. So the center of the camera is the start position, the origin of that camera. And the direction of travel is going to be, and I just want to sort of highlight this, we need a vector3 origin and vector3 direction. The direction is the forward, what's considered forward for the camera, which is the direction it's facing. That gives us a ray. We're going to do an ifs now and do a raycast. Physics.raycast is where the raycast exists, and there's 16 different options for setting up a raycast. We are going to use the ray for the first property, but we're going to press comma, and we're going to go for another option where we also want to have an output. This section here, I am defining a variable called raycastHit of type raycastHit. Obviously lowercase r to say it's a variable, raycastHit being what's inheriting, what type it is basically. RaycastHit is a type, and it is something that we can basically get the game object of wherever our ray hits. You can actually do raycasts hit multiple things as well if they're going through, but this will just hit the first thing and return that value. It returns it by using the out keyword. If you've ever done a try parse, similar kind of mechanics for that, it's a keyword to basically say if this is true, i.e. if it hits something, then set wherever it's hit to be the raycast. This will not return that in the traditional sense of a function will return. You could have a function that returns a raycast hit. It doesn't do it that way. This is a Boolean function. It will return true or false. If it hits something, true. If it doesn't, false. If it's false, it will not output anything. Raycast hit will be null. If it does hit something, wherever it's hit will be returned as a raycast hit, assuming it's something that is of a type that can, which typically it will be in Unity. Otherwise, I wouldn't notice the hit. We're also going to add in one more, which is a range, which will be our max distance. We called this range. This is just how far I want to go. I don't need that. I could just keep going, and eventually it'll hit something. I just decided to restrict the range to limit it in some way. If that's true, and it has hit something, we could ask the question, well, do we have a raycast transform? Does this raycast object have a transform? And it should do if it's a game object. So let's just ask the question. Again, the transform is this component that's in every game object. If it's not equal to null, then it's got one, and we can do our code. Otherwise, we'll just ignore it. Okay, so this is the unique part of this, using the send message upwards. We're saying if we've hit something, we're going to check its collider and send a message upwards. It's basically going to look at any code, any script files that we've created that's attached to our object here that we've hit. And if it's got a subroutine in any of the scripts, that's called hit. If any subroutine is called hit, it will try and run that subroutine, and it will pass in the single value, float value of raw damage. If hit does not have the fingerprint of having a single float value, this won't work properly. So it needs to be set up properly. Now what's that's looking for then? Go to hit manager. It's looking for this subroutine. And if it finds it, it's going to pass in a float value. It's going to be the raw damage. They don't have to be named the same, as long as they have the same type. If it hits the player, it will run this same subroutine, hit. You don't want these two files necessarily attached to the same object because they'll both run. Which it's not designed to be that way. You could actually have the same thing attached to both. The issue there is I didn't want to delete the player in the same way. I didn't want to delete them from the scene. Depends how you're setting up your game, whether you can come up with a system for that. You could certainly have a virtual class that you inherit from for the two objects. In any event, it will run that subroutine if it hits something, has a transform, and if it can find the hit subroutine. If it doesn't hit anything, let's tell us. No raycast hit objects found from our player attack. We could check this works, or we could just write up our enemy attack script. I think we'll check it works first, it makes more sense to. I'm going to go into player object and just check this out a second. Or damage 10, hit points 100, happy enough with that. Check out enemy. Hit points 25, happy enough with that. The player attack won't do anything yet. Press play. Helpful to have something in the middle of your screen so you know where the center is. Just try and position my mouse. Shot 3 times and it disappeared. Might have been helpful to have a console log every time I shot that thing. Of course I took it out, so I'm going to go back and take this ouch from our health manager, go back to this one, paste back in, but instead of ouch, I'm going to type in enemy hit and output their hit points. I hit them once, hit them twice, again. So 15, 5, minus 5, so the health deteriorated by 10 each time, which shows my raw damage. It seems to be working. They're getting removed, there's no error messages popping up. We can now move on to our enemy script. For this one, I'm going to keep my update and start, but we'll delete the comments. And I'm going to start by setting up some builds. So I've got the player's transform position, which will need to be passed in, and I'm going to do that by a simple drag and drop rather than finding it in the start. I'm going to need to have, I'm going to want a maximum distance to the target, which is going to be the range at which, if you enter within 6 units, the player will start to, the enemy will turn towards the player and start shooting them. The distance to target is something that isn't going to be set here, but it's something that I'm going to have to be able to work with. I need to know what the distance is. I could actually serialize the maximum distance, so it's in the inspector. I'll just put it in the inspector so I can see it. The distance slightly separate to those two. We'll have a raw damage again, so we'll just do 10 for every time it hits, it'll do 10 damage. We'll have a timer delay. This is how many seconds I want to wait between each shot. I don't want it to be every frame, because that means in a second it's going to issue so many hits that you'll be dead. Less than a second. So I want it to wait 2 seconds before it shoots again, and so it's going to give us a bit of time to respond. The tick is just going to be a count on the timer. It's just a temporary value, really. And attack ready is a bool set to true, a boolean, and it's going to be set to true, and the idea is that while it's counting down, it's going to set to false while it's counting down, and when it's ready to shoot, this will reset to true, so it's ready to shoot straight away. And as soon as it shoots, it's going to set to false, and then the time is going to be ticking away again until it can shoot again. Once it can shoot, doesn't mean it's going to. It's only going to shoot if you're in range, but it's going to be remain ready. So if it sees you, it'll shoot straight away. That's the idea. Right. I could have another transform for the gun itself, because I positioned that. However, thinking about it, shooting from the actual gun is yet again a problem. If you off-center the gun, the player will look, so the enemy will look at the player, but the gun could be to the side and the gun might not shoot the player because the gun's not going to be facing quite in the same trajectory as the player's center, or the enemy's center, sorry. So it's about looking at what I want to shoot from in a game sense rather than in a more reality sense. Shooting from the enemy's center position is probably the safe place to shoot from. So on start, let's set our tick to equal our delay timer. You can do this different ways. We don't want to count up, count down. This is the way I'm choosing to do it. On our update, we'll attack. Let's create our attack subroutine. Let's get the distance between the enemy and the player, so we're going to want to know that. We'll save it in our distance to target float we created. A vector3.distance asks for two vector3s to be entered into it. Oops. A and B, and it will give a distance in terms of x, y, and z as a result. So it'll return a vector3 position variance, the differences between x for each value, difference between y and difference between z. So it basically gives us a trajectory as well. No, it doesn't. A vector3.distance returns a float value. It wants two vector3s passing in, and it will basically work out what the line between those two is and return the magnitude of that line, i.e. the distance between the two. And for now we're going to store that in distance to target. We're going to do this every frame, bear in mind, so it's going to be constantly changing and updating. We then want to know if the attack's ready. I want to create a function to determine this. I want to create a function called isAttackReady. It'll create an error because it needs a return value, because it's a function, not a subroutine. It doesn't have a void. Instead, it needs to return a value, and we're going to ask the question. Is our tick less than our delay timer? When this starts, it's not less than, it's equal to. So to start off with, this is going to be false. This statement here is going to be false. However, I do want it to return false in this situation. Let me say that again. If the tick is less than the delay timer, which it's not, because the tick equals the delay timer at the moment when you first start. If it's less than the delay timer, the if statement is true, that it is less than, then we're going to return false. However, at the moment, it's not the case. So in the alternative, we don't need an else actually. I could say else return true, but I can just simply come down here and say return true here. This will never run if the if statement is return then false. As soon as you have the return, the subroutine is exited and nothing else runs. So the return value stops this happening. If I wanted something to do, if I put something else underneath here, the code would never run because the return value comes first. So if I wanted to do something before this, and I do, I want to add the time.delta time to the tick. So if the tick is less than delay timer, let's say we set tick to be 0 rather than be our delay timer 2f. So when you shoot, you set it to 0, you will add the time.delta time, which is basically how long has passed since the last frame. So if you add it all up, once 2 seconds have passed, the tick will be equal to or greater than 2 seconds. It probably won't be exactly 2, but it'll be a number greater than 2, greater than or equal to. And when it is, this will no longer run. It's not going to continue to increase our tick, our timer, if you like. It's not going to continue to increase that once we've passed our delay timer value. And the reason for that is I don't want it to keep going up and up and up and up and then cause an error where it's out of bounds, because the float can only store a number of a certain size, say. So that's the purpose for it. If it's adding the time, so if we've taken a shot, it's set to 0, it's going to add a small amount of time on the tick and return false. And it's going to, next time it's called, it's going to do that again and keep doing that and doing that until it's ready to attack. And then this will no longer be true. Tick will be greater than the delay timer. It's not going to increment up. It's going to stay at whatever value it's at, and instead it's going to return true. Let's use it. Got attack ready. Our attack ready field can now equal the function is attack ready, which will check the delay timer and return either true if it's greater than or equal to delay timer, and if it's less than, it'll return false. I'm then going to ask the question, is the distance between the target and is the distance between the player and the enemy, the distance to the enemy's target being the player, so is that distance less than the maximum distance we've set? Is it within 6? If it's within 6 units, 6 meters if you want to consider it that way, then it's going to look at the player and start attacking them. If that's not the case, it's not going to do anything, and it's going to end that subroutine and do nothing. We also want to ask the question if the attack's ready. Now I could do this. Distance to target is less than or equal to max distance to target and attack ready. I could do that, except for I want to do something first. If they're within range, I want to turn to the player, or start turning to the player. So let's do that first. Let's create a subroutine called look at target. I want to make this a little bit more sophisticated in a moment, but I'm going to start by just having, I don't need to put this, I'll just put the transform.lookat. Transform.position here is assuming that this script is added to the enemy. And it'll return the enemy's transform.position. And same here, it's the enemy's transform.lookat the player's position. So it's going to reorientate to look at the player. So Unity builds in some nice stuff for us to use, but it will click to look at, and I want to change that afterwards. For now, that'll do. So we'll click to look at them. I want to say yes, the attack's ready. Just thinking this through. Probably don't need that variable. I could have almost just return the value straight away in there like that. I'm going to keep it in for now as it was and go with it. So if the attack's ready, let's reset our tick timer to be 0. So now it's going to not be able to attack when it runs this again on the next frame. Attack ready is going to be false, because tick's not going to be equal to or greater than 2. We'll pass in the transform position and transform forward. This is where I could pass in the gun transform position, gun transform forward, but again, the gun could be offset and not shoot what the enemy thinks it's shooting at. Similarly to before, we are setting array and passing that into our raycast, outputting any object that it hits as a raycast hit object. And what we're hoping for is that that thing could be the player itself that we're hitting. Let's do a debug log. Just so we know that the enemy is shooting. Let's do that raycast hit.transform not equal to null, just to check that it's hitting something that has a transform attached. This whole section of code here is exactly the same as what's in player. In fact, a whole subroutine could almost be copied out, including the else part of that part of the statement. Even the ray. So the ray down to the if else if could almost be copied out and paste in with some minor tweaks and changes, mostly to do with adding debug logs in, or changing the debug log. Doing an else on the raycast, not on the whether it's the transform's null. just to say enemies fail to return a value on their raycast. Okay, so you can see the enemy there. I'll keep them selected so you can see sort of their forward is that blue line. As I get closer, it's got errors because I did not assign the value. Of course, we're up here. Player transform doesn't have a value yet, so we need to pass in the player object. It's got a value. You could hard code it in the start to have it find the player object and pass it in. If you've got a multiplayer game, either situation is not as clear cut as that. It needs to know where all the players are. No errors this time, that's better. Right. Now it's rotating to always look at. I thought it was not quite looking right. If I jump, it's actually rotating on a funny angle, which isn't ideal either. Something we need to be aware of. Right, see if I go out of view and then move back within view, it snaps in. Right, I've got ouch 50, ouch 40. If I move while it's trying to shoot, I think it'll miss maybe. Right, let's do that. Right, enemy shoots. It can't hit me while I'm behind the wall if I keep moving. Yeah, it can shoot me even when I'm moving, and it flips into view. So I probably don't want it to flick. I want it to move more gradually. So let's have a quick look at that. Our look vector, the direction that we want the enemy to look, is the player's position minus its own position. When we look at a bit of maths, you'll see that that will return a value that is the vector direction vector for where we want the enemy to be looking. And conversely, if we wanted to know the direction that we're looking, you could take the enemy's position and subtract our own position and get the same thing. I want to ignore the Y value just because this is all happening on a plane, and I don't want the object, the enemy, to tilt up and down for the purposes of this scenario. We're going to set a quaternion rotation called rotation, and we're going to use a quaternion.look rotation. And what that'll do is it creates a rotation with the specified forward and upwards directions. Forward is the direction to look in, so we're passing in the look vector which we've created, and it should basically find the rotation to move it to that location, the rotation we want to be at. We are now going to set the rotation. Now we don't want to just snap to that rotation, which we could do. We could just pass in the quaternion rotation that we've just found, the lookup basically, and return it, and it'll do what we originally had with the look at. Instead, I want to linearly interpolate to that position, and there's lerp to do that. Or I can use a spherical lerp, which is slurp, to do the same thing, but it's has a smoother start and end to it is the idea. You could try either and see how it works. They're both very similar for what we're trying to do. And what this needs is it needs an A and a B, and it will try and interpolate between those two positions over a period of time, which we're going to set to be 0.01f. And what it'll try and do, I could set it to delta time. See what that looks like. What this will try and do is move towards from A to B. It will slowly get there, and it will make an update based on the time setting we've set. I'm going to try time to delta time, see what that looks like. I'm hoping this doesn't snap to the enemy, the player, to the enemy to player. There we go, so he's turning. It's a bit slower than I would have liked, actually. So whenever you get within range, he will start to turn to, he or she will start to turn towards you. I'm going to try changing that back out. Having it as a variable would allow you to set it yourself. And of course, if you've got different enemy types, there could be different response levels depending on what they're like. Very similar to the previous one, that. Yeah, that's a lot faster. Now, if I keep moving now, it can actually miss because it's trying to aim directly on me and it'll shoot, and if I keep moving I'll stay out of range, and that's why it keeps returning, failing to return a value. However, if I stay on it, ooh, not going up when I jump up. There is a lot issue, it's never returning a value. Now what I can do is with the raycast out, the physics raycast, I can do a debug dot draw ray using the ray. I can't pass in the ray, so I'll pass in the same values as the ray. And I'm going to multiply the transform. Transform forward will produce a value equal to 1 unit. So I'm going to multiply it by 3, just give a bit of range to it. And I'm going to set a color to be color dot magenta. It just stands out like that. We need a duration to be longer than is currently. 0.2 seconds. I should keep the raycast there for a little bit longer to be able to see it because it's so instant. I can't see anything. I can see what's happening. The issue is it's going not from the center position. So it's now deciding whether it's an entirely bad idea having it always grounded, and I should have just gone for the center. I can either change the center position from where I'm doing the ray from by adding to the Y value, or I can go up and have it do it from the gun. And I could have it do it from the gun, and then when you want to change where the model is, change the model within the gun to be off-centered. I'm going to do that. So let's get started. Quite an easy fix. I'm going to create a transform. I'm going to call it gun transform. I'm not going to serialize this one because I'm going to set it up in the start. And it's going to look inside this game object, and it's going to look for something called gun within it, a game object called gun within it as a direct child. It's going to go into enemy and look through these two game objects and find if any of them equal gun. One does, so you need the spelling to be the same. And when it finds it, gun transform will be set. We now need to use gun transform. We don't need to do it for the look. We do need to change it for the... we could do it from the distance. Don't need it for that really. Do it from the gun ray. So gun transform dot position. I'll also change that in the draw ray just for where we're going to draw our line. Test it. There. Ouch. Hits, enemy shoots, and if I keep moving, it miss. Oh, it's moving too fast, that's why it can hit me. Or maybe I'm further on. That's not work. I did return a value there, failed to return. But stay behind here. Misses. Anyway, you get the idea. It will keep going down and it will go below 0 and it'll keep shooting, but it did have the game over script debug log mentioned. You can see the purple for where it's shooting. You can determine why it might be missing or hitting, and you could extend the length of that. As I said, I did it times 3, just increase that if you want to maybe do it by 6 to see if it's something it should see. That pretty much brings this one to a close. I noticed what I didn't do last time is I didn't seem to add this as a prefab. Yeah, I have a prefab here. I'm going to remove that prefab. Pass this now in the player prefab. Oops, wrong place. And that way this is a prefab, and I could do the same with the enemy. Create a folder. Pass the enemy in there. I can actually get it in. And then pass down multiple enemies. And each will do the same script. Pause for each one. I need to set the player object. Apologies. Okay, so that's everything I want to cover right now. Again, it works primarily in first person. I should be able to shoot in third if the player object isn't in the way. You can use layer masks to avoid hitting the enemy. Let's see if I can. No, all I'm doing is I'm hitting myself faster. If I stand over here and I shoot, I'm hitting myself. I need a layer mask in there to have it stop hitting me. So something to be aware of. And there are also issues with the enemy turns to shoot, whether it sees you or not. It's not a sight that it sees you when it turns. It's just with if you're in range. That's something that you might want to change later, but something we might have a look at later as well. So yeah, it's the starting position of having an enemy, having it do something where it might attack you in some way. I mean, you could have like, do you want a different kind of melee attack if you're close enough as well, and how is that going to work mechanically, and how's it going to look? Do you want a melee attack? How's that going to work? Are you going to use raycasts, or do you want to use some other sort of mechanic to do it? You could do some sort of collider box to determine if they're in range, and then have an attack work based on the timing of an animation sequence. All sorts of options. Thank you very much. You may like to take a look at my other videos or subscribe to be notified of future content.